light. The utilization of these energies more than 1,000 years ago led the way for humanity to enter into a new, more advanced epoch. Light is a fascinating phenomenon. Everything we see through light. For physical reasons, laser light possesses the best color properties of all light sources. In the field of laser projection techniques, systems from LDT laser display technology have realized large displays at the highest technical standard. With laser technology, animated pictures can be displayed with more intense colors and become impressively realistic. The images are produced by a laser beam being deflected from the top left to the bottom right. According to the color information, the laser beam writes a spot composed of 3 primary colors: red, green and blue. First, high-speed horizontal deflection of the color spot from right to left produces a line of light. This line of light is moved from top to bottom by a second diverting mechanism. Increasing the number of image spots produces a complete image. The phenomenon of light has occupied people's minds for a very long time. In his color theory, Goethe writes, "Colors are the deeds of light." In nature, objects absorb the light shining on them and reflect only a small part back into the surroundings. The reflected light determines the color. This is called subtractive color mixing. Laser light is artificial light. In laser image projection, it projects images by additively mixing the 3 primary colors, red, green and blue. The mixture of these 3 beams of light creates extremely saturated colors that can be reproduced in a 3-dimensional color space in the highest color brilliancy. The design possibilities that can be realized surpass those of conventional TV by far. In laser image depiction, digitalized image signals are saved and assigned to the corresponding colors red, green and blue. According to this color information, electronic control impulses are fed to electro-optic modulators. The individual laser beams entering the modulators are modulated in their amplitude according to the controlling impulses. By separately influencing the 3 modulators, you can create all the necessary colors. In the beam unification that follows, the 3 partial beams are united to form one collinear laser beam. The beam unification is composed of 3 partly reflective and partly permeable mirrors. One 100% mirror and 2 dichroic mirrors. These only reflect a certain wavelength and allow all others to pass. Coming from the beam unification, the laser beam is focused and fed into a multimode glass fiber that is 15 microns thin. Finally, the beam is transmitted through this glass fiber to the scanner, which is separated from the laser projector. Conventional projection lamps can considerably heat up the ambience. The separation of laser and scanner in laser projectors has several advantages. The projection head, which can be freely rotated, can be positioned directly in the projection room without heat being produced. The scanner is situated in the projector head and is made up of a rotational polygon scanner and a galvanometer scanner. The polygon scanner moves the individual light spots from left to right with a rotating frequency of 1.3 kHz. A line of light is produced. The following vertical diversion caused by the galvanometer scanner leads to a complete image. In all the classical projection systems, the degree of focus of an image always has to be readjusted depending on the distance between the projector and the screen. In laser projection, however, the depth of focus is almost unlimited. Focusing is not even necessary when projecting onto cylindrical or spherical surfaces, which up to now has always been difficult. LDT's laser projection technology yields revolutionary possibilities for use in the professional as well as in the semi-professional sector. The electronic panorama cinema of the future turns fiction into adventure. Theatre sets are replaced impressively fast. Large technical displays can be realized with a high brilliancy of color and over large distances. Visual communication is treading new, exciting paths. In simulation technology, dangerous situations can be realistically mastered. With the beginning of the new millennium, laser projectors will be used in the private sector as well. LDT laser display technology will press ahead with new, revolutionary methods of electronic image transmission.